Okay, I thought I'd go over some of the 3.4 practice assignment problems. So you can look at this before your quiz tomorrow. So problem 1, a normal distribution has a mean 50 and a standard deviation of 4. Determine the value below which 95% of the observations will occur. So first thing we need is at least our z table here, right? Because we know the population mean and standard deviation. So we need our z table. So let me just search Google here. Z table chart. Alright, and it's always nice to have a picture of our standard normal curve. So, standard normal distribution. And images. It's fine. Okay. So, the question is, below which 95% of the observations will occur. So if we go to our standard normal, we want to be somewhere up here. Because 95% of the data, right, is going to be below where we're at. So 5% is above, 95% is below. Go to our z table. So this is telling us how much of the data is below where we're at. So we want to go to 95, right? 95%, so 0.95. So here's 0.5 is at z-score 0. So we're looking for 0.9500 or 0.9499. Okay, so right here, between 1.6, 1, 2, 3, 4, and 1.65. So 1.645, I guess. So remember that, 1.645. Let's put that into Excel. So I want a z value of 1.645. Now, you could probably do this with 1.64 or 1.65, but I'll just go in between because it's going to be closer. We were looking for 0.9500. We can't get either of those, so we'll just go in between the two. Alright, and then the mean is 50 and the standard deviation is 4. So mean 50, standard deviation is 4. Okay, so what's happening here is we want to take our z formula. Z equals x minus mean, which is mu, but I'll just call it mu, divided by sigma, right? So that's our formula, x minus mu divided by sigma. And here the mean is 50, so mu is 50. Standard deviation is 4, so sigma is 4. And then z, we figure that out by just looking at, okay, how much data is, 95% of the data is below what point on our standard normal. That's 1.645. So we just plug all this into our formula, and we get 1.645 equals x minus 50 divided by 4. Okay, and now we just solve for x. We multiply both sides by 4. So then this equals 1.645 times 4 equals x minus 50. Now, x minus 50. Alright, so these two are equal to each other. And then we add 50 to both sides to find x, right? So 6.58 plus 50 is 56. So x equals 56.58. Okay? So what we did was, it told us the percentage of the population below a certain point, right? So 95% is below what point? So if we know the percentage we want, we already know that, we're going to try to find x. We're going to try to find the x value. Okay? So we have to go work backwards. Remember, before we were looking at, they gave us the x value and they asked, they'd ask what percentage of the population lies below this value, or what percentage lies between this value and this value, right? So they gave us the values and they asked for the proportion of the population. So here they're giving us the proportion of the population, they're asking for the values. So they gave us the proportion below 95% of the data lies below what? We have to find the z-value first. So go to the z-chart, and we found the z-value, and then they gave us the mean and standard deviation. So we just plug into our formula. We plug in the z-value at z, we plug in the population mean for mu, we plug in the standard deviation for sigma, and then we just solve for x. Right? Pretty simple. Now, if they gave us, two values and ask what proportion of the population lie between them, or something like that, that means we're starting with having to find the z values, right? So we're starting with this formula, but we have everything on the right-hand side, and then we find the z value, and then from the z value we can get the proportion of the population, right? Okay, so two problems related, but we're going the opposite way. Okay, let's see if we're right. 5658, and we had 5658. That's correct.